Hello everyone, welcome back. Today we start with our first lesson in Module 2 dealing with multiplying and factoring polynomial expressions. The main focus of today is going to be, well actually we're going to be doing both, so I should correct myself there. So let's start out here. You should have your student version of the lesson in front of you, so make sure you can fill that out and follow along. And of course, anytime I ask a question or we get to a question, feel free to pause the video, try it out on your own first, and then restart the video so you can see what to do from there. And I'll try to remind you that from time to time too. Okay, so for our first opening exercise here, and we're going to start with the opening exercise. We're not going to jump ahead to the notes first. We'll just do this here. We're asked to write expressions for the areas of the two rectangles in the figures given below. Okay, so figure 1, figure 2, and we want to find the areas of these rectangles. So to find the area of a rectangle, well, what is the formula for the area of a rectangle? It is length times width. So for this rectangle right here, the area would be the length, and it doesn't really matter which one you say is the length. If you want to say 2z is the length, or if you want to say z is the length, it doesn't really matter. So I'm just going to pick 2z. And then z would be the width, so times z. Okay, and we multiply those things together, and we get 2z squared. And that would be the area of this rectangle here. Okay? I put the little line in the middle of the z so it doesn't look like a 2. That's why I do that. All right, let's do the same thing for this one. Why don't you go ahead and try that rectangle and see what area you can come up with. Okay, hopefully you did that. And again, pause the video if you didn't and try it out. But I'm going to write it out right here. So it'll be 2z times 8, which when we multiply gives us 16z. The 2 and the 8 multiply together, and the z kind of comes along for the whoop. The z follows along there at the end. So there's our area. Okay. The next question asks us to write an expression for the area of this rectangle. Now you'll notice here they kept the colors. There's the gray rectangle that we had. There's the orange one. So a couple different ways we could do this. One way is we could remember, oh, it's 2z squared was this one, and it's 16z, so what would the total area be? Well, we can just add them together. Like that, just add the two rectangles together. On the other hand, though, we could also think of this as one big rectangle, in which case the length would still be 2z, and then we multiply by the width, but the width is going to be this entire distance right here. How could we represent this distance using an expression? Well, if this distance is z, from here to here, whoops, and if this distance from here to here is 8, then what would this total distance be? Well, again, I gave it away in the word total there. What do you do when you total something? You add. So this total distance would be z plus 8. So the total width would be multiplying there, or the length would be 2z multiplied with the width of z plus 8. And of course we can simplify this. These two things don't at first glance look like the same thing, but we can multiply here. We can distribute the 2z to the z and to the 8, which would yield 2z squared. 2z times the z would be 2z squared, and the 2z times the 8 would be 16z. And look, now we have the exact same answer, which is what we should get, right, when we do things two different ways. Okay, let's take a look at this next example. Now here, Jackson has given his friend a challenge. Jackson told his friend that the area of a rectangle is represented by 3a squared plus 3a for some real number a. So a is just a variable. Find the dimensions of the length and width. How many possible answers are there for Jackson's challenge to his friend? List the answers you find. Okay, so we want to come up with choices here that would result in multiplying together to give us 3a squared plus 3a. Okay, so there's a couple ways we could do this. All right. If we compare it to the earlier problem here, where we had the 2z squared plus 16z, okay, we can think about how we can kind of break up this 3a squared into the product of two things. So how can we break this up into the product of two things? Well, for example, we could say that 3a squared plus 3a, they both have a 3, right? So we could take out a 3, and then what would be left behind? If I take a 3 out of 3a squared, if I divide that out, what's left behind? Well, it would be just a squared. And if I divide 3a by 3, what would be left? Well, it would just be an a. So in other words, we could have a 3 here and an a squared plus a here. And that would then multiply together to give you this correct area. Okay. Alternatively, we could also flip these two and say this length is a squared plus a and this length is 3, or this distance is 3, but I think that's kind of trivial, so we won't worry about just like flip-flopping them like that, okay? We'll just keep them like kind of unique. Now, is there any other things we could take out that's in common to 3a squared plus 3a? Well, the answer is yes. What else do these two terms have in common? What variable do they have in common? They both have an a, right? So we could also just take out an a. If I divide this by a, well, I have an a squared right now, and if I divide a squared by a, I'll be left with just an a. If I have 3a and I divide that by a, I'll be left with just a 3. So in other words, the dimensions here could be a times a plus 3. Finally, there's one more situation here. We took out a 3, we took out an a. That's right, a 3 and an a are in both of these terms here. Well, since we can take out both a 3 and an a, we're going to do that. We're going to take out a 3 and an a simultaneously, which means that if I take a 3 and an a out of that, what's going to be left behind? Well, just one a. And if I divide 3a by a 3a, what's going to be left behind? Well, it kind of divides completely, right? But when you divide something by itself, you're left with a 1. Right? And again, you can check our work here by, imagining redistributing, and you would end up with this, right? Redistribute the a here, you'd end up with this. Redistribute the 3a to those two, and you would end back up with this. Okay, so there are 3 different situations. All right, we'll stop there, and in the next section, we'll get into some exercises.